Hi everyone, this is Dr. Hisham Saeed. This video will be the first part of a series of a very condensed lesson on construction cost estimate. It's a huge topic. It's a profession itself. It's being taught in a whole course or even multiple courses. But I think I can condense that into this series of videos, and of course the main idea is you need to know some knowledge of construction in terms of how things are being put together to be able to do a reliable cost estimate. So let's jump in the first video here. So cost estimate is part of the area called cost management, and is the aspect of project management that deals with setting or predicting the cost of construction or design, and to try to remain within that prediction or that estimate. So the cost management goes through this cycle from a project to a project. So you do estimate the cost, you budget this cost, so transfer from a cost estimate to a project budget, and then you control the costs of the project to be within the budget and track your performance. And that will feed into the cost estimate of the future projects. So it is a cycle, and good companies will use this cycle to build up the capital of what we call the tacit knowledge, the knowledge that is here. So they have this cycle is rigorous, and people are committed to it, and people put effort into recording costs and tracking it, because it is important for estimating future projects. Now, estimating is just the art and skill of predicting future costs or future performance. And the goal here is not to have a correct prediction, but have an acceptable prediction, having an acceptable estimate. Acceptable here means that you're covering your bases, you're accounting for the main aspects of the cost. So there are different types of cost estimates here that are done at different steps, at different points of the project life cycle. So starting from the top here, that's the beginning of the project. You do order of magnitude or kind of back of envelope kind of estimate. And then you go all the way until the bid level or the bid estimate, where contractors do such detailed estimate to bid for a project. And you can see here the amount of design information that's needed. So order of magnitude on the back of an envelope, you don't really need that much. You just ask a couple of questions to the owner, and you will be able to provide a very rough estimate here, order of magnitude estimate. But in return, the owner should expect that the error in such estimate, it would be like 100 to 200%. So it's a big margin of error here. But the more information the builder will get, the more reliable estimate you will get at the end, until you reach the bid level estimate. And you can see here the specific information that's needed for different levels of estimate. One thing I will highlight here is the contingency that you put into your estimate. So contingency is basically your money that you set aside in your estimate, in your budget, to account for unforeseen conditions or unknown things that might happen because of lack of information about part of the project. So you can see here the more detailed your estimate, the less value of contingency you have. So you reach here until around 5% contingency. If you're dealing with greenfield plant with information about such plant or a project that you did before, or work in existing plants, what we call brownfield. If you compare that to greenfield plants with historical data, so sorry, for the first case here, it's without. So you don't have any information about such a building. It's the first time to do an office building or a hospital building. So your contingency, if you do a really detailed estimate, you'll be around 5%, but if you compare it here, it will be around 3%. Why? Because here it's all about information and experience doing the same thing that you're trying to estimate. But also it's about hidden conditions that you're not aware of. So brownfield projects, or what we call existing plants, renovation projects, have a lot of risks into it. You don't know what's inside the wall, and how was the building built before. So contingency here is just a language to refer to your risk. What's the risk that you need to include in your estimate? So we do estimates based on available data to us as estimators or those who are doing the project. So if you are in a company, and the company have been around for a couple of years, probably you will have in-house cost data that you'll depend on. If you're doing public projects, for example, this one is from Caltrans. They publish cost data. So they look at all the bids that are being submitted to them. You look at the different line items in the bid, and they kind of analyze the data that they get, or the numbers. So that will be helpful in-house in Caltrans for their engineers to kind of come up with engineers' estimates of the project. But also it's used for litigation and change orders, things that they can lean onto if the contractor give them an unreliable or questionable estimate. And then there is proprietary published cost data. So people in industry don't use these that much. It's mostly engineers because contractors mainly depend on their experience in-house cost data. This is mainly kind of a reference for engineers or new construction companies, or companies who are doing new projects that they didn't do before. Now, if we talk here about the proprietary cost data or the industry cost data, which I'm showing here Gordian or RS means, these are structured based on a standard outline. So a standard coding system. So we're mainly dealing here with CSI, master format. We talked about these when we talked about breakdown structure and kind of identifying the scope of a project. It's the same cost or a standard classification system that's also used in organizing the cost data. Master format is published by CSI. Uni Format is another standard that's also published in the US. But it's mostly based on physical parts. But master format is based on construction materials and methods. So for example, if you're talking about Uni Format will represent an exterior wall as a whole assembly. And it will include wood framing, fiberglass, insulation, and drywall, interior. So interior panels of drywall. All of that in just one cost number. But massive format will represent these in 3 divisions, we call divisions. So it will be in division 6 for wood, and division 7 for the insulation, and division 9 for the drywall. And all of these division of works, like costs of work or activities that are being done, instead of assemblies as they're presented by Uni Format. So massive format currently have 49. It started in 1998, and used to have 16 divisions. So it did grow from 16 divisions to 49 divisions. And this is kind of the higher level of the divisions. You can see concrete 03, finish is 09, wood is 06. So people in industry know these divisions. Uni Format is organized in 3 levels. So the major group of elements, and then the group elements, and then the individual elements. So you start with substructures, division, you can say level group A, so substructure, and then substructure includes foundation and basement construction. And then you can break further down in level 3. So it's very useful for elemental estimates, meaning that let me see if instead of using slab on grade, I will use different type of slab system, or instead of using standard foundation, I will use a special foundation. So choosing and picking design alternatives and comparing between design alternatives is the main idea here. So this is just zooming in to show you more, like for roofing, Roof coverings, you have different types within it, roof openings. So I'm not showing, of course, the detailed here system, but just the main, the higher level of it. So the last thing here is how to create a good estimate. Some tips here. And the one of the tips here is that as estimator, you're depending on knowledge of construction. Again, you have to know how things, if you are estimating a piece of a project or part of it, you need to imagine how it's being put together. So you kind of visualize it, imagine how it's being put together, and reflect that in your estimate. So you have to mentally build the project before actually you put numbers for its cost. The second thing is the accuracy of the estimate is dependent on the accuracy of the data used. So always question the accuracy of the data you're using in your estimate. Also, another thing is you cover the whole scope and evaluate the leaks between the different packages you deal with. So you always are dependent on your specialty contractors who give you different estimates for their scopes. So try to clarify the scope between the different subcontractors here. Always focus on the large items, so don't waste a lot of effort in doing little tweaks and little cost impact here. Focus on the big ticket items first and then move to the next significant ones. Try to detail as much as you can of the estimates so you will be able to go back and review it, and also try to use the technology we have to digitize the quantity takeoff. So a lot of mistakes happen because you lose track of how many doors you counted. So digitize that by using the tools we have, like on-screen takeoff or like Bluebeam review. So these tools are very helpful. Include the units in your calculations. So like rates of square foot per hour, write it in your calculation. So when you multiply by the area, you end up with hour of time, and so you can trace the accuracy and correctness of your calculations. Always double check your calculations. Perform some calculations, especially the major ones, in multiple ways. Compare your cost to other projects. Make sense of the numbers you have, and also review each cost item to typical expected values. So mechanical, electrical systems are expected to be within this range percentage-wise of the total cost estimate. So kind of benchmarking and comparing parts of the estimate to what would you expect typically from such a project. So that's the kind of the intro into construction cost estimate. We knew about what type of estimates, the contingency that we have, and such level of details of estimates. We learn about the classification systems. We learn about the cycle of construction management, from cost estimate to budgeting to control. And we shared some tips on how to develop a good cost estimate. Thanks for watching, and I'll see you in other videos. Take care of yourself and those around you.